So, good evening to another lecture on machine learning. This is part of the GATE TA syllabus. We'll be talking in a bit of a lucid manner, in a bit of a concise manner, because time is less. But still, today we'll be learning some new algorithms as well. But before that, what the algorithm that we learned in the last class was called K nearest neighbors. And regarding k nearest neighbors and some basic machine learning MCQs, I have some questions that I would like you to solve so that you understand what is k nearest neighbors, and these are questions that are very likely to be asked in the exam. Some questions are created by me, while some questions are taken by the internet. So make sure you are able to solve them. Starting from the first question on this. What is the role of the value k in the KNN algorithm? That is correct. So the role of k means the how many neighbors will you consider for a given point x while you do a prediction. Good. Why will you prefer an odd value of k compared to an even value of k? Okay, so this option would be or vice versa. So option A says there is no effect if I choose an odd or an even value. We get a less error rate when considering odd value over even value. Uh, let's give you a small hint. Suppose the value of k is 4, okay? And let's say you are considering a point x for which your k nearest neighbors are this and this. So you are considering 4 points. What will you predict for x? Which class will you predict for x? Red or green? Hmm. That's a hint. Suppose if I had another, let's say, closest point and I considered k equal to 5. Now, which class will you consider? Let's say I remove this 2. Now k value is 3. Which class will you consider? So, which is the correct option? Good. Option B is correct. Because option C is actually very vague in the sense, uh, if you were following the last class, there was a graph which was for different values of k, the error rates were given something like this, right? And then I think the answer for k equal to 10 was giving the lowest error value. Okay, so that wouldn't make any sense if you use an odd or an even, only if it will help you to break ties. Okay, fine. So this is a question that you might not know the answer of because we have not discussed it, but Consider a two-dimensional data set. Okay? And if you consider a two-dimensional data set, so typically, how would you calculate the distance vector? Let's say if I had a Manhattan distance, okay, and let's say the value of k is 2. Oh, sorry, ठीक है, k is 2, or let's say 3. That doesn't matter here, but okay, let's take k as 3. Let's take the dimensionality of data as 2. So you have something called x1 and x2, two dimensions. Okay. If you want to calculate the Manhattan distance between x and z, what you will do is you will do something like x1 minus z1 plus x2 minus z2 mod. Okay. Let's say that point x is 1 comma 2 and point z is 3 comma 4. And you may be able to calculate the Manhattan distance. In this scenario, it will be 2 plus 2, 4. Right? Let's say that my value of x is 1 comma 1000 and the value of z is 2 comma 10,000. What is the Mahalanobis distance for, sorry, what is the Manhattan distance for this data point? What is D for this? 2 minus 1 plus 10,000 minus 1,000, which is 9,001. Okay. Can you see any problem here? Can you see any problem in this data? There is one very small issue with this data set. If you notice very carefully, just because the value at y or the x2 was much huge compared to the value of x1, your distance became huge. Correct? Your distance became huge. So how can you solve this problem? Okay. This is called feature scaling. What feature scaling does is, what I can do is, let's take x2. x2 will have something called a minimum value. It will have something called a maximum value. And each x2 of I, what I will do is, I will subtract the value with the minimum value and divide it by the range x max minus x min. Okay. What is this that I am doing? By doing this, all my values of x2 will be between 0 and 1. This is called normalization or feature scaling. Okay. And this type of feature scaling is called min-max scaling. Okay. If this is not that you prefer, there is one more thing. Have you ever heard of the word called standard deviation? Standard deviation. Standard deviation of a data set, let's say, is given small s. Then for each data point, you can something called standardize it. So minus the mean of the data set x2 divided by the standard deviation s. This is called standardization. Okay. These are the two ways by which you can convert each feature into a uniform value, in this case 0 to 1, so that you do not get such issues with the data set D. Okay. In what type of learning will you use a labeled training data? Labeled training data means you have X, comma, Y. You know the true output as well, and your model trains a function that you use to that maps the true value to the predictions in the best way possible. True value to the data is the best way possible. That is nothing but the definition of supervised learning. Okay. And out of these examples, which will you label as a supervised learning algorithm? If you are given an email that has been labeled as a spam or not spam, so you know the Y. Y denotes either it is a spam or not spam. So it's a labeled data, so that's why it's a supervised learning algorithm. If you see the other examples, given a set of news articles found on the web, group them into set of different categories. So you do not have something called Y. You just have a set of news articles. By looking at that, you will have to group them into different categories. So that's a example of unsupervised learning algorithm. And given a database of customer data, automatically discover market segments and group customer. Again, this is a clustering algorithm, unsupervised learning. You do not have any Y in it. And find the patterns in market basket analysis is also a, because you have to find a pattern by looking at the data. I mean, you do not have the access to the label, which is what is the true value or the correct value in this case. So that's why that is also an example of a unsupervised learning algorithm. Okay, before I move ahead with this lecture will be a bit short, I guess, because we will not touch more much on this lecture. We learn only one algorithm today, machine learning again. This is naive Bayes, but before I start, we need to do a quick review if you know or not. So let's take a simple example of a coin toss. Okay, so we'll do a review of machine learning probability by using only a coin toss. So the experiment I am telling you beforehand, what is the experiment in this scenario? You are tossing a coin. Okay. What is meant by a sample space? This is a question that I want to ask. What is meant by a sample space? Yes. What is a sample space? What is a sample space for the experiment? So a sample space is the set of all possible outcomes. Correct? Set of all possible outcomes. What is the sample space for the given experiment? Let's call it S of experiment. Hmm. What is the sample space of the experiment? If you toss a coin, what can be the possible outcomes? Either it could be a head or a tail, right? Head or tail. What is an event? Event is nothing but a subset of the sample space or an experiment. Okay? Since I already said the experiment on the top, that's why event is a subset of the sample space. Your event could be coin toss is head. This is an event. Okay, event means that the if you toss a coin, the outcome is head. And this is so in this case, since it's a subset of the sample space, so the event contains only one outcome, which is head. If I ask you what is the probability of the event E occurring, what it will be? It will be the number of elements in the event space divided by the number of elements in the sample space. So it is 1 over 2. This is very elementary maths, nothing I'm complicating it now. What do you mean by a mutually exclusive event? Let's take two events, E1 and E2. When can I claim that they are mutually exclusive?
You are currently the only person in this conference.
Yeah. When can you claim that two events are mutually exclusive? Two events that not happen parallelly. Okay. So if you toss a coin and you get the value of head, okay, let's say E1 denotes the coin toss is head and E2 denotes the coin toss is tail. Are E1 and E2 mutually exclusive? Are E1 and E2 mutually exclusive? If you toss a coin and get a head, can you also get a tail? Or if you toss a coin, you get a tail, can you also get a head? Good. So E1 and E2 are mutually exclusive if both of them cannot occur at the same time. In other words, in terms of mathematics, the best way I can explain is given that E2 has occurred, given that E2 has occurred, the probability that E1 will occur is what? Given that E2 has occurred, or given that E1 has occurred, the probability that E2 occurs is 0. Okay? I hope this bar you know what it is. It's called conditional probability. Given that an event has occurred, what is the probability that the other event will occur? Okay. What do you mean by two independent events? When can I say that there are two events, E1 and E2, which are independent? Is this the same as mutually exclusive? Yes, no, don't know. Two events E1 and E2 are independent. What does it mean? Good. But is this the same as mutual exclusive? No. So independent event means whatever is the outcome of one event is not affecting the other event. So probability of E1 and E2 occurring together is the same as saying probability that E1 occurred followed by the probability that E2 occurred. Okay. Typically, people tend to mug up this formula, but it is actually very simple. Let me explain why. How? So, every one of you must know the rule of P1, E1 given E2. Correct? This is nothing but probability of E1 and E2 occurring divided by probability of E2. Which means, given that E2 has occurred, okay, given that E2 has occurred, what is the probability that E1 will occur? Since you are saying that occurrence of E2 does not affect occurrence of E1, then they should be equal to probability of E1. So if you substitute the value, then what you get is probability of E1 multiplied by probability of E2 divided by probability of E2, and you can say this is equal to probability of E1. Similarly, you can derive for the other scenario as well. And if you look at the result, which is probability of E1 given E2 is probability of E1, which makes sense because given that E2 occurs, if E1 and E2 are independent, it does not matter for E1 that E2 has occurred. So that's why whatever is the probability of E1 remains the probability of E1. It doesn't matter if E2 has occurred or not. Okay. Last but not the least, Bayes rule. Bayes rule is used to find out conditional probabilities, right? And the Bayes rule has a formula P of E1 given E2 is nothing but probability of E2 given E1, right? Multiplied by probability of E1 divided by probability of E2. Typically, what you do is you flip this two. So you get E2 given E1 multiplied by whatever is on the denominator divided by, since this is a denominator, so you put E2. Okay. And just to check your understanding, how much you know Bayes theorem, I will give you two questions to solve. Take some time, but unless you don't know this, then it's hard to go forward with the lecture because today's entire lecture is on Bayes theorem only. Okay, so this is the first question. Maybe try for some time. Make mistakes, that's okay, but at least try to solve. That will be helpful for you as well. Okay, for the exam. Okay, try this out. I'll give you 2 minutes. Okay, so the first step to solve this would be to write the formula, the base formula, right? So what does it say? Three identical boxes contain red and white balls. The first box contains three red and two white. Second box contains four red and five white. And the third box has two red and four white balls. A box is chosen very randomly and a ball is drawn from it. If the ball that is drawn out is red, what will the probability that the second box is chosen? So you will have to find out something called probability that given that a red ball has been drawn, what is the probability that it was box 2? So you flip this 2, so you get probability red given box 2 multiplied by probability that you have chosen box 2 divided by probability that it is red. Okay. So what is the probability? So we'll find out the individual stuff. First is very simple. What is the probability that you have chosen box 2? What is the probability of choosing box 2? One third, because you have three boxes, you choose one of them. So 1 by 3. What is the probability that it is red given you have chosen box 2? Given that you have chosen box 2, so box 2 has 9 balls, right? And any of the 4 could be a red one, correct? Okay. You can also solve that with a big formula, P of red and box 2 divided by P of box 2, but that is a bit longer. What you can do is, given that you have selected box 2, so your sample space now confines into whatever it is in box 2, which is 9 balls. Out of 9, 4 are red, so 4 by 9. The interesting part is to calculate what is the probability that you choose a red ball, correct? Which is nothing but, you can calculate it this way: probability that it is a red ball given it is box 1 multiplied by P of box 1 plus probability that it is a red ball given box 2 multiplied by box 2 plus probability that it is a red ball given box 3 multiplied by box 3. So red given box 1. What is the answer? Probability that it is a red ball given it is box 1. Sure. Given it is box 1, you have 5 balls in it. There are 3 red balls. 3 by 5, right? Given that you are in box 1, so which has 5 balls, any of the 3 could be a possible answer, multiplied by 1 by 3 plus this we have already calculated, 4 by 9 multiplied by 1 by 3 plus the probability that given it is box 3, the ball is red is 2 by 6 or 1 by 3 multiplied by 1 by 3. Correct? Now you need to calculate this value. You will get some value. Okay. I'm not calculating, that you can do. Don't have a calculator with me now, but I think that will be straightforward. And if you plug in those value here, you will get the answer. Okay. Fine. One more question will do. Oh, yes. Hmm, what is no question? You were seeing a broken image. Um, how about now? Ah, okay. Okay. Need some time more, or should I solve? Okay. In a bolt factory, there are three machines, M1, M2, and M3. They manufacture 2000, 2500, and 4000 bolts every day. Of their output, 3%, 4%, and 2.5% of the bolts are defective. One of the bolts is drawn at random from a day's production and is found to be defective. What is the probability that it was produced by machine 2? So it's very simple now. So what you have to do is, okay, it's funny. Hmm, just a minute. Yeah, yeah, okay. So you have to calculate probability that given it is defective, what is the probability that it came from machine 2, right? To say this, you just flip the bits around. So what is the probability that it is defective given it is machine 2? multiplied by, what is the probability that it is of machine 2 divided by, what is the probability that it was defective? So what is the probability that if you have a machine um, that the uh, you have selected machine 2, 1 by 3. What is the probability that it is defective given it is machine 2? Given that it is machine 2, not machine 1. Correct? Other way to look at this is there are 2500 bolts, 4% of them are defective. So it is like 100 bolts are defective. Um, oh, okay. So there is a small mistake in this question. The answer will be a bit different because no, sorry, the question is correct. My answer was wrong. So probability that it is from machine 2. So you have manufactured one bolt, right? Today, let's say I manufactured a bolt. What is the probability that it was a machine 2? Out of the 8,500 bolts I manufacture per day, 2,500 come from machine 2. They are not uniform, right? All of them don't produce the same number of bolts every day. Machine 2 produces something else, right? And what is a defective? So out of 2,500 bolts that machine 2 produces, 4% are defective, which is nothing but the same only 0.04. 4%, right? Okay. The probability that machine 1 is 8,000, out of 8,500, 2,000 of them are produced by machine 1. So the probability that it is of machine 1 is this. And the probability, good Aditya, probability that it is defective given it is of machine 1 will be 0.03. And what is the probability that it is of machine 3? It is 4,000 divided by 8,500. And probability that it is defective is 0.025. Correct? Now you can plug into this formula. So you only have to calculate the probability that it is defective. So for that you can say probability that it is defective given it is machine 1 multiplied by probability that it is machine 1 plus probability that it is defective given it is machine 2 multiplied by probability that it is machine 2 plus probability that it is defective given it is machine 3 multiplied by probability that it is machine 3. And with this you can plug in the value and get the answer. Okay, this was asked in one of the GATE CS exams. From there only it has been taken. Okay. Hmm. Huh. Now let's actually go ahead and extend this concept by a very small question. Look at this data set. Okay. This data set, let me explain, consists of variable x, which denotes the weather at a given day. Some day it is sunny, some day it is rainy, some day it is overcast. And the column play denotes the target label, which is y. whether you will play or not that day, whether any player plays or not given that weather. If I say that the weather today is sunny, can you tell me that will the player play given this data? Can you model this question in the form of a probability question? Can I model this as part of a Bayes theorem question? How? What will be the thing that I calculate? What will I write in the LHS? Probability what? Mm, are you given the weather or you given the play? Do you know the weather or do you know the play? Sure. I am asking you whether the player will play or not. So how can it be given? It is given that the today's weather is sunny. So given that today's weather is sunny, will the player play or not? Let's assume I calculate this and I get a value, let's say again 0.2. Can I say that the player will play? Yes. Let's say I tell you what is 0.2? What does the value 0.2 mean for this probability? If I ask you this question, what will you answer me? That will you play? Will you say no, sir, 0.2? What do you mean by 0.2? Can I say that I don't think you will play because you have 20% chances of playing, because the probability that you will play given it is sunny is 0.2, and the probability that you will play that you will not play given it is sunny is 1 minus 0.2, which is 0.8. So you have 80% chances of not playing, 20% chances of playing. Just by this thing I wrote, whatever I wrote in the slide, you convinced that I'm not bluffing? Whatever I'm saying is the result that I'm getting. I'm not speaking out of the blue. Are you convinced by that, or you're saying, are you thinking that this doesn't infer it? Whatever I calculated, it won't infer that. Given that today's weather is sunny, my probability says with 20% chances or probability of 0.2 that the player will play. Is this correct statement? Yes or no? Correct, right? And I can say that with 80% chances that given the weather is sunny, the person will not play, which also means that I can be 80% sure that he will not play. So most likely he will not play. Correct? It's a probabilistic model. It's not a determinism model. You're predicting something. Okay. Can I somehow calculate this value? In this example, I gave 0.2. Can I somehow calculate this value? If I use Bayes theorem, can I say this is equal to the probability that it is sunny given I play multiplied by the probability that I play divided by the probability that it is sunny. Correct? This is nothing but Bayes theorem. All this while, nothing I have changed, nothing I have written extra, nothing I have written new. What is the probability of yes? Can you calculate it given the data? Is it possible to calculate given the data? What is the probability that you will get a yes? If yes, what it is? Can you calculate given the data? What is it? What is the probability that the play is yes? Out of let me give you you don't have to calculate. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. There are 14 samples. Out of 14 samples, you have yes in 5 6 7 8 9 10, right? So 10 by 14. So I'm just asking whether the play is yes or not. I'm not considering the weather, correct? The other thing that I can do is, can I calculate that what is the probability that it is sunny? Out of 14 choices, 1, 2, 3, 4, 5, 6. 6 by 14. What is the probability that given it is given I will play, it is sunny? So look at all the points where you are playing. These are all the points where you are playing, right? So this is in total 3, 4, 5, 6, 7, 8, 9, 10. 10 outcomes where you are playing. Out of them, the weather is sunny in 1, 2, 3, and 4. So it is 4 by 10. You can plug in the value and find the answer. But sometimes you might also think that I am taking a long cut. In the sense, what I could have done was probability that I will play given it is sunny is nothing but what is the probability that I will play and it is sunny divided by what is the probability that I will it is sunny. Correct? So what is the probability that I will play and it is sunny? You can also calculate with the data given. If you look at the instances, these are 1, 2, 3, and 4. So it is 4 by 14 divided by 6 by 14. So you'll get the same answer. Correct? Okay, fine. Hope this is clear. There should not be a doubt in this one. Okay. This is simple. This is not very difficult. But let's take a very small example again. Just a minute. Yeah. So let's take a very small example here. Let's take a coin toss. Okay, let's take a coin toss. And let's say that you don't know the probability that you will get a particular outcome, could be head or tail. Let's say the outcome that you will get you will get head is theta. And you somehow don't know the value of theta at all. Okay, it could be a biased coin. It's not always 1 by 2. Let's say it's an old coin. Maybe you'll get one outcome more than the other. So let's say it's theta. You don't know the value of the variable. So you want to estimate the probability of what it will be. How will you do it? Let's say you don't know the value of probability that When you flip a coin, you will get a head. Let's say I want you to estimate the probability of it. How will you do it? Let's say I give you one way. Let's say what you do is you toss the coin 10 times, and these are the outcomes you get: tail, tail, head, 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 tail, head, tail. So 5, 6, 7, 8, tail, head. Let's say these are the 10 outcomes you get. Can you now estimate theta? Which is the probability that you will get a that out of that the coin toss will be a head. Can you now estimate it? You can say that out of the 10 times I tossed the coin, 5 times I got head. So I can say that the probability is 0.5. Correct? Understood or not this one? Understood or not? Something very simple, right? Not I'm not bullshitting around here. Let's say the second experiment is instead of tossing it 10 times, you tossed it 20 times, and number of tails you get is 11 and number of heads you get is 9. Can you estimate the theta now? You can estimate saying 9 by 20, which is 0.405, correct? Or 0.45, sorry, 0.45. Okay. Now, let's say you are in a hurry and you want to estimate the probability that it will be a head, and you tossed it only 2 times and you get this outcome. Okay, just a second. Yeah, you get an outcome, this. Can you tell me the probability you will get head? What is the probability given this data on the third where you only toss it twice, you get both tails? What is the probability if you look at just that data and tell me the probability? It's very simple, you'll get 0. Now let's say you have trained a machine learning model which predicts that the value of a coin toss will be either head or tail, and this is the model that you have built. You looked at the data and then you estimated the value of theta. Your value of theta came as 0. What will your model predict every time? Let's say you are on a World Cup, you are on a World Cup match, and the big screen says the probability that today the coin toss will be head is 0. Then is it a fair thing to do? I mean, it's more like the captain of the match will always take the tail call, right? Because your model says it's 0%, man, right? It's just, you will never get head, but that you will get 0. You will get tail always. Why was it 0 now in the third experiment? What was the reason behind having 0? You had lesser data, correct? You only did 2 experiments. If you would have had done more experiments, then you would have had more data. If you had more data, your estimate of theta would have been better, correct? So that is why every time in machine learning, more the data, better will be your model. Okay, fine. But um, let's say you are arrogant. Okay, I'm giving an example just. You're arrogant and you say, no, I will only do twice. If it has not come twice, both time it has not come head, it's okay. So typically what you are trying to do is, given a model, the theta you are trying to estimate is how many heads did I get divided by how many heads plus how many tails. But if I tell you that this is something you are doing wrong. What you will tell me is, hey, actually, see, what you might tell me is, whenever I buy a new coin, I buy under a simple assumption, I buy under a very simple assumption that the probability that I will get head is 1 by 2. Okay? Whenever I buy any coin, one assumption that I always make is that the probability that the toss is head is 1 by 2. So what I will do is, apart from 1 by 2, notice very carefully, I have done the experiments and accordingly now my output will change. In the sense, now if I calculate the value for this example, it is 0 plus 1 divided by 0 plus 2, which is 1/4, which is 25%, 0.25, 25% probability. This is a better estimate of probability compared to this one. Do you agree with me? Yes or no? This is a better estimate of probability, right? I mean, you had a prior belief. So this was your prior belief that, hey, before I can say that the answer, the probability is 1 by 2. You might use it multiple times and the coin has become rugged or something. You still want to see the efficacy of the coin. So apart from that 1 by 2, you are seeing that you are seeing 0 heads and 0 tails, but your probabilities has reduced, become 1 by 4, but still not 0. This concept is called smoothing in machine learning. Very important concept in machine learning, might be asked in the exam. Why do we do smoothing? You know the answer. What is smoothing? You know the answer. And if you are putting plus 1 on the top, this is called plus 1 smoothing. This technique is called plus 1 smoothing. Okay. Now, why did I teach you all this all of a sudden? See, let's say you want to estimate that you will get heads given theta. Given the theta, what is the estimate that you will get heads? So if you write Bayes rule, it is nothing but probability of theta given heads multiplied by probability of getting a head divided by probability of the theta parameter. Now look at the equation very, very carefully. What is this P of H? This P of H means what is the probability that you are getting a head? Does it talk about theta at all? Does it talk about theta at all? No. What is the probability of head initially in the coin is what I said 1 by 2, which is your prior belief. Prior belief you say is probability of head is 1 by 2. And what does the left hand side say of the equation? Given that you have observed something else which is theta, what is the probability that your coin toss is head? This is the experiment we are trying to do to estimate theta. So, given that you have a variable theta in your expression now, what is the probability that it is head? Your prior belief might be changed given the value of theta. Your prior belief that it was 1 by 2 has changed now because it has become 1 by 4 now. Correct? This is called posterior probability. See, these are just terms. I'm just explaining the terms. Don't mug up the terms, okay? Probability of getting heads, which is your prior belief that it was 1 by 2. Given that belief, how has your probability of head changed, which is a posterior probability, given the new experiment that you have done? In this case, we call it theta. It might change your prior belief, it might not change as well. When it will not change, look at the first example. In the first example, your prior belief is the same as the posterior belief. Your prior belief was the probability is 1 by 2. If you again plug in the same thing over here, you will still get 1 by 2. Correct? So how does your prior belief change given your posterior belief? Correct. Given the experiment you are doing, how does your prior belief change? Okay, that is why Bayes theorem is very popular. Bayes theorem is why it's popular because of you can estimate the probability of data, probability of your model given the data. Theta, you can say it's a data, right? That is why in the previous slide, when we tried to solve this question, given the data you have, you had a prior belief P of yes, correct? Looking at the data, your prior belief was, yeah, I will play 10 out of 14 times. But given that it is sunny, given you have some data now, how does your prior belief change, which is called posterior? Given that it is sunny, how can you say that you will still play? Got it? And the this denominator part is called evidence. What is the evidence you have that it is actually sunny? Do you have any proof that it is sunny such that your prior will change? Okay. And this thing, this part, the name of this is called, given that you are playing, given that you are playing, what is the probability that it is sunny is called likelihood. Okay. This is called posterior. Your posterior means prior and posterior, right? Prior means before, which is this one. Posterior means after, which is after you look at the data. How does your belief change? And this is called the likelihood, which is given that it is yes, how likely that it is sunny, and probability that it is sunny is your evidence. Okay, fine. Now, today you might think that we are not even talked about machine learning at all, right? But no, given the data and given this Bayes rule, you can tell me now what is the probability that you will play, and that's how my model can tell you that. So what will now happen is, let's say you are coding it up on a computer and your computer throws in a value 0.2 as a probability that it is yes given it is sunny. Has something either or not. 0.2. What will your computer output? If I give it to your computer, what should it output? Should it say I will play or should it say I will not play? It has to give some prediction, right? You can't just say 0.2. If I don't know probability and if I ask you will I play, you will say no, 0.2. I will say what is 0.2? So how will you say? Will I play or not? Yes. Let's say you are a machine learning expert. Okay, I have given you this data to build me a model. Okay, I am a client. You made the model and I ask you that, hey, today is sunny. Will I play? What will you say? Will you say yes or no, or will you say, sir, point two? I will ask, what is point two? I don't know point two. What will you do? Do you know about if statements in Python or C program? What you will do is, it is point two. If the prediction is greater than some threshold, let's say it is zero point 0.5, your model will output that, yes, sir, you will play. If it is less than or equal to zero point 0.5, you will say that, sorry, you will not play. So, given that the probability is zero point 0.2, and I ask you, will I play today? Your model will output what? It will output, no, sir, you will not play. Understood what I'm trying to speak? It's not Hebrew, right? Anything that I'm speaking now. Hope it is understandable, right? Let's say that your model now predicts that it is zero point 0.8. If I ask you, will I play today given it is sunny? What will you answer? What will you answer? You will answer yes, right? Come on, it is greater than zero point 0.5, correct? Your model will output yes. So, is zero point 0.5 a good estimation always? Let's say what I'm asking is, let's say this was cancer data set, okay? Which means given the person's age, whether the person has cancer or not. Okay, let's say it's that data set. Okay, and let's say that so it is age, and the output is whether the person has cancer or not. Okay, for this data set, if I say that it is zero point 0.5 the threshold, you will unnecessarily harm or unnecessarily give tension to many people, right? If your model says 0.55, sir, your age is 26, and the model has predicted that 55% chances you have cancer. Sorry, sir, you have cancer. You are telling the person, yes, sir, you have cancer. So in these scenarios, what you can do is you can raise your threshold, right? You can say that the threshold is either, let's say you will say zero point 0.8, right? Then you will be more sure. So unless and until you do not get a 80% probability, you will not say that the person has cancer. So it's not always true that you will always have a zero point 0.5 as your threshold. Okay. Now, in this example, the example that I taught you, the data was a single dimensional data, correct? I mean, the value of D is 1. You only have one feature, which is what is the weather, correct? Here, in this example, you can see that there are not one feature, correct? Read the question carefully. Given all the previous patients I have seen, below are the symptoms and diagnosis. These are the different symptoms. Whether the person has chill, yes or no. Whether it has a runny nose, yes or no. Whether he has a headache, mild, strong or no. Whether he has fever, yes or no. Whether the person has a flu. Let's say if I ask you, do you believe that the patient which has these symptoms are given down, whether he has flu or not? This is the question, correct? How will you model this? Again, your probability, you have to find out the probability that the person has flu, which is flu is yes, given this data x equal to small x, correct? Is equal to, what is the probability that x is equal to x given that the person has flu, multiplied by what is the probability that flu is yes, divided by what is the probability that x is equal to x. Okay, This is what Bayes theorem, again, same thing is there, nothing is different here. Now, what is the probability that flu is yes? Can you calculate this and let me know quickly? What is the probability that flu is yes? Something very simple, right? 3, 5, 6. Huh. 3, 4, 5. Huh. 5 by 8. Correct. Hmm. The thing is to how to calculate this part, correct? Huh. So this is where naive Bayes algorithm comes into picture. Naive Bayes does a small assumption. Okay. Naive Bayes does a very small assumption. Naive Bayes, what it does is it takes into point picture two main observations and two very important observations. So this is naive Bayes. Okay. It has two observations. Number one, acha. Number one, you will only tell me what it is. Let's say that if I asked you whether the person does not have flu, what is the probability? Okay. Among these three terms, there will be one term that is unchanged. Can you tell me which is that term which is unchanged? What is the term that is unchanged? Given that he does not have flu, given a person with some characteristics X, what is the probability he doesn't have flu? Or what is the probability that he in fact has flu? There is one term that is unchanged. Can you tell me which is that term? You will calculate the probability that flu is no. Is this changing? Is this probability term changing? Previously it was 5 by 8. It is still 5 by 8? Yes? It is still 5 by 8, right? Nothing, no change? Think. What is the probability that flu is no? 5 by 8 only? Why 3 by 8? It is changing, right? You understood why it is 3 by 8? Correct. I'm just confusing you. Okay, don't worry. I'm just be confident, okay, whenever you say. Sometimes I do like this only for you to be confident. So, okay. Will this change? I haven't taught you how to calculate it now, but will this change? Yes, right? I mean, given that the flu is no, if you look at the previous example as well, huh, so which is this term changing, the denominator? No, because it does not depend on whether the person has flu or not. This is just the evidence, right? So this is the first thing, that is the observation, that whenever you are calculating the value using naive Bayes, you will never calculate there is no need to calculate the evidence. Okay. But this is not the real probability. Whatever naive Bayes calculates is not the real probability, because you're not considering the evidence. To get the real probability, you will have to divide it by the evidence. But naive Bayes says that the thing that you have to do, whether the person has flu or not, does not depend on the fact that whether the person has whether the does not depend on the evidence. So that is why you can freely, safely not calculate it. The second observation that he had was, this Bayes guy has, was the features, which is your xi's, are independent given the data label. What it means is P of x given x given any y is nothing but the product, this is the product sign of I equal to 1 to d, dimensionality of the data. P of x is nothing but, okay, you will look at the first dimension, which is x of I is equal to small x of I given y. Okay, this is the example, which means for the given example I had, the value of d was, value of d is what? Value of d is 4. So for the given example, the probability that of the likelihood, which is x given x, is nothing but p of x1 given, what is the target? Flu is yes or no, right? So given yes, multiplied by probability that x2 given yes, multiplied by probability that x3 given yes, multiplied by probability that x4 given yes. Can you calculate each of these individual probabilities by looking at the data? We just calculated it earlier, right? You have to look at each of these data set one by one, each of these feature one by one, and calculate. For example, let me do it for the first one. X1 denotes whether the person has chill or not, right? Whether the person has chill or not. Your data set has the person has chill. So what is the probability that the chill is yes, given that the flu is yes? Can you calculate this given the data? Given the flu is yes means you are looking at which samples? This one, this one, this one, this one, this one, which is you are looking at 5 samples. What is the probability that you have chill among these 5? 1, 2, and 3. So it will be 3 by 5. Got it? Understood? Let me know. I can repeat if you didn't understand. First, the assumption. Then, how do you calculate for each individual feature? Is it fine? Yes. So now, let's say the second feature is x2 denotes runny nose. The person does not have runny nose. So probability that x2 is no given the person has flu is what? Can you look at the data set and tell me the answer? Very good. 1 by 5. What is the probability that given x2 equal to x3, sorry, x3 is what? Mild. Given the flu is yes. What is this? 2 by 5. Correct. What is the probability that x4 is what? Yes, means a person has fever given the flu is yes. What is this? Person has flu, given a person has fever, given he has flu. 2, 3, 4 by 5, I guess. 4 by 5. Okay, correct. Right. So now, can you calculate this P of x, given y? You just have to multiply all of them. You will get some value 3 by 5, 1 by 5, 2 by 5, 4 by 5. Correct? And this is 6 to 5, 624 by 6 to 5. And you can, okay, let me just change the question back to what it was. Let me remove these arrows. Okay. Yes, 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 and you don't have to calculate the evidence. So you can calculate this value. You can calculate this value. Okay. You will get some value. Let's do it maybe 24 by into what is the probability that flu is yes? I think I'd calculate somewhere, right? 5 by 8. So it is 5 by 8 multiplied by 24 by 6 to 5, which is 3, 3 by 125, correct? So 3 by 125 is a probability that the person will have flu given the characteristic, right? You can also calculate the person who will not have flu given the characteristics, and then you can find out that whichever is the higher number, and you can say that if this is higher, then you can say that this person does not have flu. Okay, fine. Okay. Okay, so I think I hope naive Bayes is clear how to solve the how to calculate for a given thing. How will you calculate for the naive Bayes? Hope that is clear. With this, I think I will stop here. I won't bog you much. Maybe this revise probability more. Try to solve more questions on Bayes theorem and probability distributions. Please make sure you are aware of it. Tomorrow we will start with one of the most important concepts called linear regression, which is not very difficult, but still it's there in the syllabus. It's not very difficult. I can assure you that. The intricacies behind linear regression is the optimizer and all that. That will require some time to learn, but again, that is not again very difficult. This was a difficult algorithm in the sense you have to do a lot of calculations and all, but very important algorithm. And if I am sure, I think by 95% probability, I can say there will be one question from naive Bayes, something similar to what I solved here. You will be given this data set, and you will have to find out what is the acha. I'm scared. I'm actually a bit surprised you do not have a one question, right? All of these are categorical variables, right? What if they were continuous? Let's say this variable was, instead of this, it was age, which is a continuous variable. What would you have done in that scenario? And let's say the question would have given that age is a normally distributed variable. Have you studied probability distributions, Aditya? Yes. So if I say that the variable is normally distributed, right? If I say that the variable is normal distributed, you know the probability function, the PDF of a normally distributed variable, 1 by sigma root over 2 pi e to the power minus x minus mu by 2 sigma square. Do you know this formula? Have you heard of it? I might be wrong. Something similar to this only it was, right? Normally distributed, if it is Poisson distributed, what it is. So please go ahead and revise those because those are there in your GATE syllabus as well, CS syllabus as well. Okay. I actually do not have much time to discuss on it. But I can recommend you some lectures if you want to go through. They are very small lectures, and he has taught it beautifully, only gate level. Okay, I can do that sometime later. But again, okay, let me stop the recording at first.